Hello everyone. So today we have 3 to the power of m plus 3 to the power of m equals to 60. M is the unknown. So we're going to solve together. Let's seek solution. Our equation 3 to the power of m plus 3 to the power of m is given to be 60. So here, what is common is 3 to the power of m. If we factor out 3 to the power of m, the next line becomes 3 to the power of m, open in bracket, 3 to the power of m divided by 3 to the power of m, 1, plus 3 to the power of m divided by 3 to the power of m, what we have is 1. We'll close the bracket, this all equals to 60. So that if 3 to the power of m open us this bracket, what we have is the previous line and we are fine. So we're going to add what is inside the bracket, so the next line becomes 3 to the power of m times 2, 1 plus 1, which is equal to 60. And we're going to divide both sides by the coefficient of 3 to the power of n, which is 2. So that 3 to the power of n times 2 all over 2 equals to 60 all over 2. And if we do this very well, we're going to have 2 cancel out and it's left with 3 to the power of m, which is equal to 60 over 2, that is 30. So here we're going to take log to base 10 on both sides, so that log 3 to the power of m will be equal to log 30. But log a to the power of n can be written as n log a. That is, the power comes to multiply the log. So we're going to apply it here, so that the next line becomes m times log 3, and this is equals to log 30. Here, m is the unknown, so we are going to divide both sides by the coefficient of m, which is log 3. That is, m times log 3 all over log 3 equals to log 30 all over log 3. So that log 3 over log 3 is 1, and 1 times m, that is m, equals to log 30 all over log 3. But 30 can be split into 10 times 3. 10 times 3 is 30. So in the place of 30, we're going to replace it with 10 times 3. So m becomes log 10 times 3 all over log 3. But log a times b is represented as log a plus log b. Log a times b is in the form of log 10 times 3. So the next line becomes m equals to log 10 plus log 3 all over log 3 all over log 3 in separate fraction. So here log 3 can cancel out to be 1, so that m is equals to log 10 over log 3 plus 1. But 10 also can be written as 5 times 2, so that m will be equal to log 5 times 2 over log 3. And if we implement this law, the next line becomes m equals to log 5 over log 3 plus log 2 over log 3. And don't forget, plus 1. Here also is plus 1. M is equals to log 5 over log 3 plus log 2 all over log 3 plus 1. But log A over log B can be written as log A breaks B. So that here we have M will be equals to log 5 breaks 3 plus log 2 base 3 plus 1. And this is the value for m. We can check this if this value of m can satisfy the original equation. So from the original equation, we have 2 times 3 to the power of m equals to 60. So that 2 times 3 to the power of log 5 base 3 plus log 2 base 3 plus 1. We want to show if this is equal to 60. But a to the power of m plus n can be written as a to the power of m times e to the power of n. So we're going to apply it here. The next line becomes 2 times 3 to the power of log 5 base 3 times 3 to the power of log 2 base 3 times 3 to the power of 1. Can this be equal to 60? So a base number raised to the power of log of the same base is 1. So 3 to the power of log 5 base 3 becomes 1. What is left is 5. This is 2 times 5 times 3 to the power of log 2 base 3, also 1. What is left is 2 times 3 to the power of 1 is 3. And this want to show if it is equal to 60. So 2 times 5 is 10. 10 times 2 is 20. 20 times 3, that is 60. So 60 obviously is equals to 60. That means it's true that the value of m is equals to log 5 base 3 plus log 2 base 3 plus 1. Because it satisfies the original equation, the right hand side is equal to the left hand side. Thank you for staying tuned. Please subscribe to our channel. Help us grow. Bye bye.